All right, guys. So this problem is one that I created a video about 7 years ago, and I made a mistake. And about 6 years ago, somebody told me about it, and I said I would re-record it, and I didn't do that. And today I was reminded about the fact that there's a mistake. And so we're going to record this one quickly so we get to replace that wrong video with a right one. And that looks a lot nicer on the light board. So here we go. For those of you who are taking Calc 1, this is your first time watching it, so you will have one without any mistakes, hopefully. All right, so let's go ahead and take a look at this problem where we're looking at the equation y equals x squared minus 9, and then we're going to grab and notice that the intercept would be plus minus 3. So we're going to grab a point here at 2, and at 2, this point is going to be 2 squared, so 4 minus 9, so 2 comma negative 5. So the question is, find the slope of the tangent line, or find the equation rather of the tangent line. And the tangent line that I'm going to draw here, which is going to be the tangent line to the graph of y equals x squared minus 9 at the point 2, negative 5. Of course, it's not drawn to scale. You see here you have 9 units and you have 3 here, sort of off scale, but it's okay. We just need to know how to compute the derivative and evaluate it. So what is the strategy here? The strategy will be, firstly, we're going to find the derivative. So call this function f of x. You could just call it y prime, but I want to evaluate it. So I'm going to call it f of x, rather. Let me erase with the. And find f prime. That's going to be our first step. Because whenever we want to find the slope of a tangent line, we want to talk about the derivative evaluated at that point, 2 in this case. So 2. Evaluate. Once you have your derivative, you can evaluate your derivative at the x coordinate of the point, which is going to be 2. And what that is going to give me is going to give me the slope. So you have a slope. Your slope is going to be f prime of 2. And your point 2, negative 5. You can compute the equation of the line. So my first step is going to be to evaluate this derivative. At this point, we're using the limit definition. So we're going to say that the derivative of this function is going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. And here, f of x plus h would be equal to grabbing f of x here, so x squared plus 9. But every time you see an x, you're going to plug in now x plus h. And you're going to use your parentheses so that you don't make mistakes. So x plus h in place of x squared. So you see I'm evaluating right there. In place of x, I'm just plugging in x plus h. And now minus 9, that is already in the function. So that right there shows me how to compute f of x plus h. Of course, I'm going to FOIL this out. Remember, it's not just x squared plus h squared, but it's x squared plus 2xh plus h squared minus 9. Because you have to FOIL this out, OK? So now with that in place, I'm going to do as we did before, that I'm going to subtract f of x. So it's going to be negative x squared plus 9 So what am I doing there? I am grabbing this one and I'm doing the negatives of it. So negative and negative, negative is positive right there. And then I'm going to add them. And so what things cancel? Well, we'll see that this one right here cancels with this. And this one right here cancels with this. And all I'm left with is 2xh plus h squared. So now I'm in position to evaluate here this limit, which is going to be, let's see if we can fit it, is going to be f of x plus h minus f of x is going to be just 2xh plus h squared all over h. And I forgot to write the limit. That's a very common mistake. So don't do that. Let's put here limit as h goes to 0. And at that point, we can compute the derivative. I'm going to have to move over. I want to keep the graph though. So I'm going to move over to this side, to this side, and we'll complete our calculation there. All right, so let me erase this. It's going to be the limit as h goes to 0 of the expression that I have here, but I'm going to factor an h out of that. So the h that multiplies and the h that divides cancel, and then I can compute my limit. So this is going to be 2x plus h all over h. And here my h's will cancel. One multiplies and one divides. Remember that I cannot go ahead and just cancel this and this because I have to cancel each one of them. So be very careful with that. So now whenever you compute your limit, there's no dependency on h on this term. This one is going to go to 0, and the whole thing is 2x. Once you have it like that, what you're going to do, well, that was step 1. We finished step 1. Step 2, so what you're going to do is you're going to plug the x coordinate of your point. In this case, x equals to 2. So f prime of 2 is going to be 2 times 2, which is 4. And so now you just have to do your point slope formula to compute the equation of the line. So 3, you're going to do y minus the x coordinate, the y coordinate, sorry, of the point, which is going to be negative 5, equals your slope. And this is the mistake I made in the last video. The first time I recorded it, I wrote the slope equals to 2 instead of 4, which I had computed. It happens. So here, x minus 2. So when you solve this here, you get x plus 5 and then 4x minus 8, which gives you the equation y equals 4x minus 13. And now what I should have said at that point, and I would have noticed that I had a mistake there, is if you plug your x coordinate into your line, into the equation of the line, so in this case you plug 2, you get 4 times 2, 8 minus 13, negative 5. So you get this value back. Because what that's telling you is that the equation of the line and the equation of the parabola here match or intersect at that point right there.